Hi everyone, we're going to take a look at the greatest common factor and the least common multiple in this video. In the first part of the video we will define the terms and run through a couple of examples that you should be familiar with from past math classes. And in the second half we're going to run through a couple of examples where we will use prime factorization to work them out. So the greatest common factor then is the highest number that divides evenly into two or more numbers. We abbreviate it as GCF, greatest common factor, and we can also call it the highest common factor. In our example, we're going to find the GCF of 12 and 30, and we're going to do that by listing the factors of 12 and 30. And that means those numbers that divide evenly into 12 and divide evenly into 30. So our list of factors of 12 are 1, 2, 3, 4, 6, and 12. And our list for 30 is 1, 2, 3, 5, 6, 10, 15, and 30. Now what we're looking for is the greatest common factor. And we notice that we have more than one factor which is common, right? We've got 1, we've got 2, we've got 3, and we've got 6. But we want to choose the biggest out of all of those, and that would be the 6. And so the GCF then for 12 and 30 is 6. So the least common multiple is the smallest number that is a multiple of two or more numbers. So just to refresh your memory as to what a multiple is, a multiple is the result of multiplying a number by an integer, okay? Not a fraction, by an integer. So 12 is an example of a multiple of 3 because I can go 3 times an integer 4 to get 12. So 12 is a multiple of 3. I can times 3 by a negative integer, so 3 times negative 2, which gives me negative 6. That makes negative 6 a multiple of 3. So in this example, we are going to take a look at finding the least common multiple for 5 and 3, okay? And the way we do that is we list the multiples of those numbers, okay? So when we do our list for 3, we start at 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18. And if I want to make the list bigger, I can go 3 times 7 is 21. And I can keep building my list like that, okay? It can go on forever. And all of these numbers, 3, 6, 9, 12, 15, 18, 21, are multiples of 3. Okay, and then I'm going to build my list for 5. I go 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25, and I can build it again. I can go 5 times 6 is 30 and keep building my list. Okay, but I don't need to go any further because I can see that my lowest common multiple, the common multiple that is the smallest, is 15. It's the one that first appears. There are more than just 15 as a common multiple, okay? Other examples include numbers like 30 and 45. They're not the only ones, but both of those numbers are divisible by 3 and 5, right? So 30 divided by 3 is 10, 30 divided by 5 is 6. And if we build our list off into infinity, we'll find that we're going to have an infinite number of infinite number of common multiples, okay? But we're interested in the smallest one, which is our least common multiple. Okay. So our least common multiple for 3 and 5 then is 15. Okay, so in the second half then of this video, we're going to look at 2 examples. Okay, I'm going to ask you to add a few things. On your notes, I just asked you to find the GCF for example 1, if you can also include lowest common multiple. And for example 2, I've only asked you to find the LCM, if you could please include GCF. And also for example 2, change the numbers to 18 and 48. Okay, so we're going to use prime factorization to figure out our GCF and our LCMs. So on our first example then, what we're going to do is we're going to take 16 and we're going to write it as a product of its prime. So we're going to prime factorize it. So we're going to divide by 2, which is our smallest prime number, and 2 goes into 16 8 times. And then 2 goes into 8 4 times. And then 2 goes into 4 2 times, and we can't go any further than that because 2 is our smallest prime. And so we circle our primes. And then we'll do that for the 24. 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times, and we stop there because 3 is a prime number and we can't go any further. And so we circle our primes again. And then we will do the same thing for 36. So 2 goes into 36 18 times, and 2 goes into 18 9 times. And then we find that we can't divide 2 into 9, so we go to our next prime number, which is 3, and 3 goes into 9 3 times, and we stop there because 3 is a prime. And we circle all our prime numbers. And then what we're going to do off to the side here is we're going to write each of our numbers as a product of its prime in exponential form. So 16 becomes 2 times 2 times 2 times 2, which is 2 to the 4th power. 24 is 2 times 2 times 2 times 3, so that is 2 to the 3rd power times 3 to the 1. And generally, I wouldn't ask you to put the 1 there, but I'm just going to leave it there because we'll come back to it later. And then 36 is 2 times 2 times 3 times 3. So 2 to the 2 times 3 to the 2. Okay, so how do we find GCFs and LCMs using prime factorization? All right, well, for GCF, what you want to do is you want to choose the smallest, or the smallest exponent. So I'm using a down arrow for smallest exponent of shared factors. Okay, that word shared is important because we're looking for a GCFC common, meaning it has to be common to all of them, so shared between all of them. And for our LCM, we are going to choose the biggest exponent. Use up arrow for biggest, okay, exponent of each factor. Okay, each meaning that it doesn't have to be shared. Okay, so I'll use a yellow highlighter for GCF and the blue one for LCM. And our GCF, then we want to choose the smallest exponent of the shared factors. So we have to look at the factors that we have for 16, 24, and 36, and we have to choose the one that's common to all of them or shared between all of them, which is the 2. We've got 2 to the 4, 2 to the 3, and 2 to the 2. What we want to do is choose the smallest exponent, which means we're going to choose 2 to the 2. Now, we're not going to choose a 3 because 3 is not common to all of them. 3 is only a common factor for 36 and 24, not for the 16. So my GCF then is 2 to the 2nd power, which is 4. Okay, so now we're going to look for our LCM. We want to choose the largest exponent of each factor, okay, whether they're common or not. So we have 2 factors here. We've got 2's and we've got 3's. We want to choose the factor that has the highest exponent. So for the 2's, we have exponents of 2, 3, and 4. So we're going to choose 2 to the 4. That's the biggest exponent. And for the 3, we're going to choose the 2 because it is the highest exponent, right? We've got an exponent of 1 on this 3, 2 on this 3, so we choose the 2. So our LCM then is going to be 2 to the 4 times 3 to the 2, which is 16 times 9, right? Because 2 to the 4 is 16 and 3 to the 2 is 9, and that gives us 144. So our GCF for 16, 24, and 36 is 4, and our LCM for 16, 24, and 36 is 144. Okay, so maybe what you might want to do is to put your video on pause and try the next example on your own, and then turn the video back on again after you've completed the question and check to see how you did. Okay, so let's take a look at 18 and 48. We will prime factorize 18. So 2 goes into 18 9 times, and then I can't fit 2 in, so I have to go to 3, and 3 goes into 9 3 times. Circle your primes. 48, 2 goes into 48 24 times, 2 goes into 24 12 times, 2 goes into 12 6 times, and 2 goes into 6 3 times, and circle your primes. Okay, off to the side, write each number as a product of its primes. So for 18, it's 2 times 3, 2 times 3 to the second power. And for the 48, it is 2 times 2 times 2 times 2, which is 2 to the 4th. Times 3. Okay, so our GCF, we want to choose the smallest exponent of shared factors. Notice this time we have 2 factors that are shared between our numbers. 2 is shared, as well as the 3. We want to choose the smallest exponent, so we have 2 to the 1 and 2 to the 4, so we're going to choose 2 to the 1. And then for 3, we've got 3 to the second and 3 to the 1, so we're going to choose 3 to the 1. And so our GCF then is 2 times 3, which is 6. And for our LCM, we want to choose the biggest exponent of each factor. Okay, so for the 2's, we're going to choose 2 to the 4. That's our largest exponent, the 4. And for the 3, we will choose 3 to the 2 because our 2 is the larger exponent. And so our LCM then is going to be 2 to the 4 times 3 to the 2, which is 16 times 9, which is 144. Okay, so that concludes our introduction to section 5.2, common factors.